welcome to the 5th lecture in aspect-oriented software development. Let's go directly to the lecture, and then we can talk maybe about your project presentations and what's coming next and so on. We talked about the theme approach, theme doc and theme UML last time. This lecture has no theme mentioned in the title, but you will see that we will get to the theme again very quickly. We talked about use cases and their position in aspect-oriented software development in the first lecture, but that was kind of long time ago, so you might have forgotten this. I'm going to remind you a bit of this situation where we have two seemingly unrelated use cases: cancel an order and place an order in an imagined eShop system. And if we elaborate on those use cases, we will see that there is some overlapping structure and maybe even behavior, but behavior is actually, I didn't correct this, even here, so order product, one parenthesis is missing, so order product and cancel order, different behavior, but kind of some of the structure is repeated, and it seems as if from different perspectives. Yeah. So in order to have a complete order manager, we would put these two together. Not exactly a kind of aspect-oriented programming you encounter in Aspect-J, but a bit different way, a bit different strategy, yet we also perceive this as aspect-oriented modularization. We call it symmetric because these elements are of equal quality. These elements that are being composed are of equal quality. We cannot say that this order manager affects this one or vice versa. However, if the composition, this is a kind of a trivial example, but in a more realistic situation, we would probably need to, we will have some partial methods in one and the other class, or maybe we will have several, like several partial classes like this, and these pieces of behavior, related behavior, might have to be composed either on top of each other, instead another one, and so on. So in that case, we would have to introduce some rules how these pieces are composed, and on at this level, this deeper level, we would find surprisingly that symmetric aspect-oriented modularization starts to look like asymmetric one. So it's kind of a yin and yang, and it's also for asymmetric aspect-oriented modularization the same, because you know that we have these this introduction, or it's called these intertype declarations in aspect J, which are more of more like the symmetric aspect organization. Although we put these constructions in aspects. Nevertheless, the point here is that we have here such a composition, and this is not a complete scheme of how these two order managers are composed. You might ask a question, where are the aspects here of that? So if we go further and elaborate this, we might come to something like this theme composition. This is another example. So I'm not working with eShop anymore. So this is our theme UML example. So we actually do not have to just to imagine that composition simplified as I did in the previous example, but we can take it one level further, and then we have even possibility of specifying behavior that belongs to these structural elements. So here we have this shut down the system theme, and have this alarms theme, and it seems that if we get back and the back and forth, here we compose these two order managers, but we actually are composing these two collaborations that realize these two use cases. So virtually it is as if we would be composing two use cases. We are not composing just order manager and order manager, we are composing also product and product, but these might be the same, or some other classes. And there might be some other classes that we also compose. Here we compose these two situations, and here we have this alarm class that has only one operation stated, and this one is quite richer. So we have here even this turn off operation, which might be just repeated. So some things are overlapping, and maybe it shouldn't. Maybe I didn't have to put it here. Maybe this should have been just a basic alarm specification or model, but nevertheless these are kind of two, and these are indeed packages, because in UML these are packages, two packages that are being composed, and here these two packages are actually these two use cases. So we are here, we think of composing two use cases as two perspectives on the system, and here we call these things themes. So can't we say that a theme is or corresponds to a use case, and vice versa? This does not look like very much as a use case, because it's very structural, and there's only one element there. Of course, we might we should a bit forget about this. Back there, about this. If you read the seminal book, Writing Effective Use Cases by Alistair Coburn, you might remember this picture. And also I show this picture on several occasions. What we need to forget about is that what is the most important about use cases, that we need to follow user goals, and we want these use cases. We don't maybe for successful system development we might not even need to write down all of them. We need to target the most important ones, and why we do this? How do we do this? We talk to our client, or imagine our client, or talk to other members of our team, and we write down the steps, correct them until we agree what is to be implemented, because it's much cheaper to write a sequence of steps than hundreds of lines of code, or even less, and then to have to rearrange it again and again and again, because we are just guessing what there should be, and that code would never be readable. We need to make it runnable. It will never be readable enough for lay people, like clients. It's also who do not know what that particular programming language. So even to experts who don't know that particular programming language. And use cases, you don't have to make them runnable. They are not runnable, but they are readable, understandable. And this is the kind of the philosophy behind use cases. But then there is this technical part. The technical part is that we are specifying in natural language what is going to happen in our program, and we can do this at this level of user goal use cases, which are essential to us for successful development, for discovering what the system should be. But there are also deeper level use cases, which might be like include only use cases or extend only use cases. And this is just one level, but we can go even deeper, and by this we can specify most of what's happening in the system. And then we could even connect the actual program lines to these things, to these use cases, to particular steps of these use cases and such things. And we've done some work on this here. It creates a bunch of other problems, but it shows you exactly, you can really at any moment find your use case and rearrange what's necessary. Because when you are rearranging things, when you're changing system, the change requests come in the language of use cases from your client, and you have to translate them to your architecture language, to your programming language, and find your use case elements scattered all over your code. So there is much more to this, but for this moment, it's important for us to understand that we can use use cases also as a technique of specifying behavior, much like instead of programming. And there are also these flying use cases, like in the clouds, which are useful to tie the things together. So you can have a use case that shows a typical sequence of user goal use cases, how it is executed, or even the overall use case. But these are not these are things that these things are not implemented like this. These are not. They are not. I don't think they have the corresponding image in the code. So these are not important at the moment for us. So if you want to create an overview, if you want to create to give an impression of what is kind of happening as a big picture, then you can use these. So anyway, use cases. So if we get back to this, we can say also that what we're showing here is representable by collaborations, just like with use cases here. So these are collaborations of some elements, and these collaborations of these partial elements are composed. What would you call an aspect here in this picture? What is an aspect? Is it that this alarm and alarm are aspects? Or is it that this is an aspect and this is an aspect? These themes. These themes are not called, these are like those base themes. In the theme approach, distinguishes between base themes and cross-cutting themes. Colloquially, we call cross-cutting themes aspect themes. So base themes are not aspect themes, are they? Or maybe they are. From the symmetric point of view, even base themes represent just partial views or some views of the system. And to make the system complete, you need to compose them. They're composed like on a peer-to-peer basis, like equal basis, but they are composed. These are not like normal class diagrams that you're used to, that show complete classes. So these are packages of partial elements, and they're connected into one view, into one. Another word for a view is aspect. Do you know what is the etymology of aspect as a word? Aspect. Can you omit this A? This is usually A is kind of not that significant as the rest of the word. So if you omit this A, and focus on this spec, can you remember any other English word?
Spectator.
Spectator. Who is a spectator?
Someone who observes something, some events.
Watches something, who observes something, sees something. Spectacles, glasses, another word for glasses. And this is from Latin, spectare, which means to watch. Just like view, so your aspect is a view of something. So we are actually composing different views, and we are here even in terms of terminology. So this is one view, this is another view. So these partial elements are put together because they make a certain view together. They are related, and this one is like left alone, but it could be that there would be different elements there too. So I was lazy to elaborate to this example. So we are composing these just like with these peer use cases and seemingly unrelated use cases. So this is the same, and why am I talking about this that much of length is that I think it's important to understand in symmetric aspect-oriented composition what is an aspect, where we should look for aspects, and these are more like collaborations of related partial elements than individual partial elements. So these are our aspects which are composed together. So practically, if you don't like the theme approach, and if it's not kind of close to you, which why would it be anyway? You can use use cases instead. But you need to go one step further behind this perspective, or maybe this perspective like this. Maybe you've done this in your models, but you couldn't. Your tools usually do not allow you to provide partial views like this. But you can bypass this even in we heavily use enterprise architect here. You could put the two different versions of order manager in different packages, and then you could provide different inside of these two elements there. And then you should elaborate on this and in different diagrams do something like this. So it would be necessarily coming to something very close to the theme approach, but you will be thinking in your use cases. Maybe you will be using use cases in more technical sense. So that's one thing to consider. How can we do this in aspect J? How can we package elements and have these? But this is a different thing. So I think we're done here with this symmetric aspect oriented composition and use cases. Let's get to the second thing, which is the extend relationship. So if we recall this example, which I was showing to you, of conditionally skipping operations. I'm showing just this aspect here because it's interesting, because it packages everything it needs almost. So this is an interface, and this point cut is defined with respect to this interface, but there is this behavior. This behavior specified which, through which you affect something. But what do you actually affect? You need a concrete aspect to specify this. So this is something that is applicable to different situations, and this condition operation comes through the interface implementation. So something would need to specify, to implement this interface and to implement this abstract point cut. These are two abstract parts there. This is something, and it could look like this for our alarms. So we just use this declared parents construct in order to enforce implementation of interfaces. You can even enforce implementation of classes, but in Java you have only one such relationship. So if your class already spent this relationship, you cannot do this again. You will get a compilation error. With interfaces it's different. So in order not to get the compilation error, you need to make your alarm class really implement this operation, this condition operation. And here's our point cut. So we make our point cut like this. And I thought I would have this idea of the extent relationship between depicted what I have in the picture. So practically our exclude alarms connected to special sensors. Affects our alarm use case, to say so, or aspect. So we can, in use cases, we could say something like this. So if you would have this use case, which is not a normal use case, but technically you can take it as a use case, like this, and this one is called exclude alarms connected, so exclude and so on. This is the relationship that we are actually targeting by this. So aspect J enables us to compose this more or less. If you look at this kind of, it's not, this situation is not that complex, but it could use several interfaces and so on, and define things in terms of that. So this constitutes. So this is a kind of internally you define type that you are using. So you're defining your own small world that then you impose on something else. And this small world is a view, your view of the system, your aspect of the system, and it is successfully, in aspect J even, successfully packaged into one unit, into one aspect. So this is something to consider. Then we can think further about this theme approach. What actually, or one more thing here. Here I'm not saying this operation class is exactly alarm, but I'm saying that I need something here to play this role of an operation class, and then I impose this role on the alarm class. This is one thing, one very important thing. So we are, in defining our partial views, and even in the theme approach, we think of, and it is more apparent with those aspect themes, those cross-cutting themes. We think in terms of roles, not in terms of specific elements. And this is so also in use cases. When you talk about transferring money from one account to the other account, you think of source and destination account, okay, but source of some money and destination of some money, and these source and destination things might be accounts at one point, might be some other things at the other point. And even if it's always your account, it takes one role and the other role, and the money is being transferred. And then it is released from, or relieved from this role, and can play another role. And these accounts and such things are kind of deep, represent a deep basis, structural basis of your system, your application domain architecture, to say so. And use cases represent kind of ever-changing user perspective of the system, and how you perceive the behavior over this stable structure. So your stable elements are taking these roles and play them in order to make an impression with the user that these are the kind of these elements the user imagines in their head, and can easily manipulate them. So this is something that brings us to this, that the elements in themes are actually roles. So we are designing things, so aspects are actually sets of interacting roles, and we are composing these sets of interacting roles into a greater whole. Yes, and this is something. This will be kind of a very awkward picture. But it's not my notation. So just for the moment, let's forget a bit about the notation. Maybe we are used to something else. But anyway, there are nodes, there are edges. And just let's look what's inside. So the upper perspective gives us this frame that defines some kind of job offer producing thing. There is some job offer producer, there is job offer and job offer consumer. So this is kind of a part of our of an imaging system for improving the work market by providing support for people to get to job offers and for job offers to offer some jobs. The other thing is that your job offer might require some prerequisites. So it kind of contains prerequisites. And these circles, actually this means multiplicity. So one job offer, and it's reversed from the opposite way that we are used to. So job offer requires, job offer producer might produce many job offers, and this is many-to-many relationship, so it's easy. And these circles actually represent interfaces in this notation, but it's not important at the moment. What is important is that we compose these two views into something like this, and this is our kind of our whole, or the basis for our job offer system. So one perspective is this, one perspective is this, one view, one aspect. And if we go one step further, then we can see here something a bit different. So no longer we talk about job offers here, neither we do talk about job offers here. These are more general aspects now, just like themes. So we have in the team aspect, we have this operation class, and we do not talk about alarm as such. So why is this important? To decouple these things, what opportunity this does give to us when we forget about job offers in this and this perspective.
We can implement them in the different ways.
In different ways.
Or different situations.
We can reuse them. Yeah, so it improves reuse by simply not thinking exactly about what you need at the moment. So you actually can create such partial views and reuse them, and you actually can do this successfully maybe overall, but usually we focus on a particular domain, and for that domain we develop these partial views and the partial components, maybe aspect components, and then we are able to compose them in different ways. The other people maybe will not be able to put them into their context directly. So I'm not promising a completely generally applicable design here. That would be probably an overkill for us. And furthermore, the technological perspective would also get us on our way, because we will be programming this in some programming language, and other people would need this in some other programming language. So what's more important is the idea, the rest is the simple matter of programming. So what is this actually? This is object-oriented role analysis and modeling, ORAM. And this is roughly, what year do you think this is from? Roughly 1993 or something like that, maybe even before. 1993. Way before aspect-oriented software development. And do you know who is the author of this? Do you know the name Trygve Renskaug? It's a strange name to us. I always like to surprise students by this, and I managed to surprise them repeatedly. So Trygve Renskaug is the one who came with the idea of model view controller. Model view controller is something you all heard about. Model view controller has different interpretations, but the idea, these names or the parts of this pattern, sometimes it's not denoted as a pattern, but it was presented as a pattern at the beginning. This is something that Trygve Renskaug came with. He is an old guy now, but still manages to work and collaborated. As far as I know, I'm not following this past few years very much, but he was collaborating very much with Jean Coplin and promoting something like this. And you might know that in UML you also have roles. Association roles. You know that when you have a class, one class A and the other class B, okay, like this, you can say that, and even you have these visibility markers like plus, usually it's a public thing, so this plays, I don't know, a clock role to this. This class plays a clock role to this class. And on the other side you can also have a role in these collaboration diagrams that we had, not collaboration diagrams, collaboration specifications. So I did not put roles here, but I could have to make things clear. But anyway, these are roles to me now. So this is something that got its way to UML as well. And actually, Trygve Renskaug was involved in this, in restating UML. You might know that you're modeling not very much in, not exactly in UML, but in UML2. When you look at the specification of UML, the current version, so you will see that the version of your UML is you work with is UML2. Okay, that's more specific number that designates the exact version, but UML was restated, reestablished. And the idea was to put forward this concept of role, but it did not succeed that much. And you can see roles also in composite structure. When you draw components, you have those parts inside. That you can draw a component and then you can draw parts. What are those parts? Sometimes we think of them as objects, but sometimes we do not assign any type to them. So they are free of any type, and we consider them some kind of roles that some elements will take and play these roles. So these mysterious composite structure diagrams are related to this as well. So unfortunately, we do not have these capabilities directly in UML, but this is something, as I said, very much related to aspect-oriented modularization, but predating aspect-oriented modularization for quite some time. it is intriguing that no aspect, no paper related to aspect to the theme approach. And I think I was not able even to find any other paper that relates this work of Trigger and Scout to aspect orientation. So it was completely ignored. Maybe the authors of the theme approach simply rediscovered this idea, because the idea is the same. Don't be fooled by this strange notation. We can easily change it to something else, into something that we are more accustomed to. So it's interesting and intriguing that there is no such relationship established in the literature. Not quite because I did establish it in one or two papers, but I would expect many people to talk about this.
Next question.
Never heard that.
Can those interfaces, that upper one and that on the right side,
Yes.
can be considered as one single theme, or they are two separated, which are implemented in the one composed? So the interface is producer, item and consumer, and item and part.
Yes.
Are they two different themes that are composed to the one, or they can be considered as a single one theme?
These are not considered interfaces. These are considered interfaces, and they're marked like this with these abbreviations. And these are roles. And I think of a whole frame as a theme. So this is a theme, and this is a theme, and this is what we never showed when we were looking at the theme diagrams. This is the composed view. Most often you don't need this. You don't need to exactly see this. You need to see the specification of how things are composed, and you work here, and you work there, and you work on the composition, but you don't want to see the overall mess.
Okay, understood, thank you, but can we use such notation in our aspect J part of the project, where we have to use and find some theme, and describe it like that, so we can have some roles?
This notation?
Yeah, something like that. Or that which you showed us previously?
I would advise you to use, for this notation you would need to study this book. There's a book on this, probably, to some extent. So I don't want you to bother you with this that much. If you want to do an experiment and use this instead of the theme approach, we can agree upon that. So if you are attracted by this, it would be an interesting thing.
Okay, thank you.
So look at this, consider this, but I think we know more, and this theme approach is kind of closer to our perception of modeling. It's close to UML. And this kind of, I think, well, this notation is quite elaborated. It's not just this diagram, and there are sequence diagrams involved there, and all kinds of things, and it's a complete, really a complete, it is a method called ORAM. So it's not just spelled like this. So this is ORAM method, a whole method. It's not just annotation. So, why do I have this here? Yeah, like this is to just to remind you of this extension situation. So I've already related what we saw to this in that example that actually was intended for a different purpose, but I used that opportunity to also to mention this. So this is just that example that we had at the first lecture with this eShop system, where we have modified the stock plan use case extending place and order. The diagram is one thing, but how it is being done is the other thing, and it's the text that we need. So we usually use extension points. That's something. That's one thing that we might consider at this moment a bit, and related this to aspect-oriented programming. So extension point, we could address directly a step. That's for sure. But we use extension points as labels because the order of the steps might be changing, and we do not want to make our use cases inconsistent. So when we define this extension point here, we've actually done nothing. It's just labeling. No changes in behavior. Nothing happens. Just a label. And if we move step 4 somewhere else, we know, because this is one use case overall, we need to check everything when we are moving steps around and so on. So we will remember to check the labels and see, oh, step 4 is no longer step 4, it's step 3 now, or whatever. So that's why this is very helpful, and we need this and we use this extension points. What do we do with extension points? Make extensions to them. And here's our extension that we had before. So it's just that at that point where the product availability is being checked, we signal if some more products need to be brought to the store. Yeah. So, and we say after the checking product availability. So it's just like a piece of advice. Of the after type, after, like not before, not around, but after. Okay, so it's clearly you see that this is just like aspect-oriented programming. This is something that we know. So I'm just reminding you of this. And we know that in implementation we can proceed like this and target this join point by an aspect that could look a bit like this. This was not probably very understandable at the beginning, but now, as you mastered the aspect-oriented programming version available in aspect implemented represented by aspect J, so you can read this and understand. Okay, I never correct this. This is a product. For those who do not speak Slovak, this is the product here. Never mind, it's not important. Just a sketched example. It's not completely correct, but the idea is there. So we know that this is so. I was expecting something else here. We will get back to this and analyze this statement that I showed accidentally, but let's think for a moment whether these, how do these extension points correspond to some particular aspect-oriented notion, and which one? So what would you say, what does correspond to an extension point in the aspect-oriented world, in aspect-oriented programming, particularly in aspect J? But it's a general notion, more general notion. It's also a point. We do not call it extension point.
What aspect?
Yeah.
Not aspect, because
Not
aspect can extend our functionality.
You think this corresponds to an aspect?
Probably, yeah. It can
Okay.
be.
That's one opinion. So this is an aspect. It's interesting. What else could it be? It's not necessarily a construct in the an expression, or there is no statement like that in aspect J, but it's a notion that we operate on. How do you call the places?
Point cut.
Point cuts. You're closer, but it's just one point. What are point cuts?
Some places where we will call as aspect, which we are going to catch in the process.
Are point cuts places?
Events.
They are close to places, but they are not exactly those places. They are sets of places. It's different. They're not those places. There are specifications, more exactly. There are specifications of the set of the places that you are going to address, and those places that you are addressing are called this is an essential notion. Join points. Join points are just like extension points, or extension points are just like join points. They are places that we are addressing, but our point cuts, remember, they are actually sets, even though they might be one element sets. There might be just one join point defined by point cuts, still it's a set. It's a different level. And they might be even empty. If you miss any join point, so it's an empty set. The aspect J development tools will warn you of this, with a mark, that your point cut is not addressing anything. But for the time being, you might it might be all right, because you'll be adding some code that will be eventually addressed by that point cut. So it might not be a mistake as such. So extension points, and you said these are aspects. Why do you think these are aspects?
I think I was a little bit wrong, because exactly extension points here, you're right, are more likely like join points, and aspects are going to be something like those extensions. So those use cases which extends the main one.
Okay, I accept your apology, but I didn't want you to apologize at all, because you were right. Do you, in aspect J, do you mark your join points? Do you say this is the join point that I want to catch?
Yeah, we are talking about some events where what we are going to catch. But
Now you will have to apologize.
But
this
fourth step is
not-
not an aspect. This fourth step is a
No.
moment where we have to try to catch this event and
Yes, but if you imagine a class and there are some calls, there is some method, there are some calls that you are catching there.
Yeah.
You do not mark these calls by any construct. You do not say this is something that that I'm going to catch by some aspect. In your base code, you do not put any labels, anything.
Of course, I put some functions names. No.
Function names, okay, function names. But you need function names anyway. For if you would not think of aspects, you would have function names or method names. Okay, they might be like more catchable or less catchable. That's one point. There's something in what you're saying, but you might write your base code without any preparation for aspects. And then you write your aspects with respect to what you see in your base code. Sometimes it's easier to operate on it if you named your methods consistently according to some naming convention, then it will be easier for you to catch related methods, of course. So that's something to consider. But you do not say, oh, these are my join points here and there and there. And now just this aspect just names these already indicated join points in the code and just put this additional behavior there. You do not do this. So we do something that we do not usually do in aspect-oriented programming. We actually prepare, not exactly prepare, but we name the place that we are going to affect. It's a bit strange. It's a bit strange. We can use Alistair Coburn's notation and avoid defining extension points. There is a way to declaratively say whenever there are products missing, product availability is activated. We can do this. This looks like more like our aspect-oriented programming. Even it's a bit on a bit higher level. In declarativeness, but here we explicitly name this, and we are actually expecting some additional behavior here. So this is a use case that should not be aware that it is going to be extended. Our base code should not be aware that is going to be extended. Yet, we indicate this and spoil the thing. So the basic idea, our initial idea of aspect-oriented programming was this. Aspect-oriented programming is quantification and obliviousness. Obliviousness means not knowing, not being aware of something. I'm oblivious to something, I'm not even interested in. So our base code is oblivious of aspects, not aware of them. And quantification means that we are addressing usually many join points. That's why our point cuts always define sets. And usually, we address, and this is where the strength, where aspects are strong. You can affect hundreds, thousands of places, similar places in your code with just few lines of code, without changing these, without any need to change these places. So this is quantification, and obliviousness is that these places are not, but anyhow they are not prepared for aspects. However, as Mikita indicated, if we know that we are going to use aspects, we either consciously or unconsciously start to prepare our methods for this. The naming conventions, the order of arguments, number of arguments, whatever, whatever we can prepare or manage without affecting what we really need to express by our program, we can do this and prepare this space more for to more easily accept aspects. So so the class names as well, and actually this is something that can go way further, because I did not talk very much about, or actually maybe I've never mentioned that you have a whole lot of other point cuts in aspect J that are based on annotations. So you can have annotations in Java which practically are just labels, but some frameworks use them to manipulate code. Reflection, but essentially they were meant to be labels. Maybe compiler can use some annotations. So if you put some annotations like override, and you do not, and you actually break this in your programming, so you actually what is it? If you have override and then you do not if you do not provide a different version of this method, then the compiler complains, issues a warning or something like this. I forgot this at this moment. Or is it vice versa? You mark by the override annotation the places that are intended to be overridden, but and then you can control whether you do so or not. This does not affect the behavior of your program. So you can also mark by your custom annotations places in your code. So you can mark all the methods that need to be captured by some aspect. You can forget about their names. Their names could be different. And what you can do actually, you can write a point cut that captures all the methods that are annotated with a particular annotation first, and then use this annotation to mark the methods that you need to capture. Your base code is then no longer oblivious of aspects, and you reverse this, and you spoil a bit of your base code because it kind of starts to show this an additional line which might not be very appealing, or like this maybe distracting from the intended purpose of the code. But you gain some stronger control over what your aspects do affect, and you do this from the other side. So it's not that easy as Philman and Friedman declared some 20 years ago. And this kind of aspect-oriented programming, when you write your aspects in terms of annotations and then annotate the places that you want to affect, seems to be more acceptable to people. Because one of the fears, and very strong fears, from aspect-oriented programming is that something is affecting my code and I do not know about this. I have no way of finding this. I don't want this kind of programming. Somebody will spoil something and I'm responsible for this, and it's crazy. This is something that was very much emphasized, and is emphasized when we talk about, when the topic is aspect-oriented programming. So this is something that we discussed exactly this thing. This is just a summary, but I wanted one more thing. Where do we have anything related to that? I'm not seeing it. Well, I don't have an appropriate slide, but one of the things that one more thing to think about related to this, as we said, that join points are actually addressed by point cuts, which are actually sets of join points, is the idea of how strong your point cuts are. Can they survive? And if you are marking your places, your join points in your code, you're fully in control what places are these, so your point cuts get much stronger. The price for this is that you need to mark those places, of course. Otherwise, if you write a very good point cut and somebody changes the base code, your point cut might fail. There are ways. We used this control flow thing. Control flow primitive or elementary point cut is very useful for this, for dealing with the ever-changing structure of your code and structure of calls, because you can capture all the calls in the control flow. So you can make your point cuts stronger or less strong, or more or less fragile. The fragility of point cuts is one of the topics in aspect-oriented programming. So you might be happy with one version of your point cut. Okay, it works, it captures what I need. But when you look at it more closely, you can see that if you can assume some changes in your base code, you can see that it will not survive. That it can be made better. So that's one thing to consider with respect to what I talked about, this quantification and obliviousness. We'll get back to this topic at one of the remaining lectures. Once more, at least I think. Let's close the whole thing like this. So one of the things that we observed in this analysis of of how use cases and the theme approach and some kind of object-oriented role analysis by Trigger and Scout are related, is that aspects can be seen as role collaborations, role interactions, or whatever you call it. But when we use this expression collaborations, we can also relate this to the exact UML element that we use to express this. And the other thing is that with aspects, use cases can be preserved in code more or less. Okay, you can regulate this, but since even in aspect J, aspects can package different, very like different a whole world that, or a partial world that you need to impose onto something or compose with something. If your own interfaces and classes defined inside of this, and then the whole mechanism that you need there, defined there, you can actually package these things, package all the things that a use case needs, and the use cases are defined in terms of roles. So you're never mind you call them interfaces or even classes. These elements will be conceptually representing roles. So that's the other thing to take out from this lesson. Okay. Is there anything you would like to get back to? Or is there anything you would like to get back to with respect to the theme approach? Okay, then you can close the lecture like this, and we have some time to just for me to see how are your presentations scheduled and so on, but we can do this during the break, so I'll ask just Jakub for this. Okay, so this is it. I guess we will meet next time. We will be talking, if I'm not making a mistake, about the component perception of aspects. So there are some languages that have been defined that are not particularly interesting to us as to program in them, but the ideas behind them are interesting. Just like with this ORAM method, which you will probably not use directly, but the philosophy behind it can be applied even with very different notations than this method prescribed. Okay, thank you very much. See you then next time.